Hi everyone, welcome to my YouTube channel Techie Code Buddy. I hope you are doing extremely well. Replacement preparation is also going well. Well guys, first of all, if you are new to this channel or haven't subscribed this channel till now, then do consider subscribing this channel as this really motivates me to make more such content for you and for replacement preparation. Well guys, in this video, we are going to solve a coding question that is recently asked in Accenture exam. You guys were requesting me to make videos on coding questions asked in Accenture. So this is the next video, okay? You can check previous videos in the playlist of Accenture coding. I will put the link in the description as well. So let's start with the video now. So this is our first question. In this video, we will be solving two questions, okay? First of all, let me take the pen. So this is the very first question. There are n stairs. A person standing at the bottom wants to reach at the top. The person can climb either one stair or two stairs at a time. This is the condition. Okay. Now count the number of ways the person can reach the top. Order does matter. Okay. Here order does matter. Now suppose n equals to 4 and there are total 5 possible ways a person can reach at the top. Now let's just take if n equals to 1. So only one stair will be there. That means only one stair a person have to climb to reach at the top. Okay, so this is the top of our and this is our base and this is our top. All right, and the person is standing at the base. Now only two ways to climb the stairs. Either he can pick one step or he can pick two steps. All right. Now as there is only one stair, so he will take only one pick, right? Or I can say he will only take one step and he will be at the top. So the total possible ways is one only. All right. So here one will be the output. There is only one way to climb one step. Now suppose if n equals to 2, that means the total count of stair is two stairs. Okay. So now the person have to climb two stairs. Now how many possible ways are there that a person can reach at the top for two stairs? Okay, so this is our base and this is our first stair and this is our second stair. All right, just a minute. Yeah, this is our second stair. Now the person is standing at the base. Now, in how many ways he can reach on the top? So if he can pick one step, then one step, so he can go so one step and one step. So this is the one possible way. All right. Now, just let me take the eraser. Now, if he take two steps directly and jump at the top, so he can also reach at the top. Now, is there any way? Is there any way to reach at the top? As he can only take one step or two step at a time, so he can reach the top. So from here he take one step, so he will reach at the stair. Okay, and from here if he directly jump by taking two steps, so he will reach at the top. So there are only two possible ways. Now if I take n equals to 3, then how many ways are possible? This is our ways. So this is our first stair and this is our second stair and this is our third stair. Now how many ways are possible? So suppose the person is standing at the base, so he will first take one step and one step and he will reach at the top. All right, so he will pick one step and he will be reach at the top, and this is the one possible way. Now what he can do is, the second possible way is, he can go first one step then jump, then he can directly jump onto the top by taking two steps. So what are the possible way? First he take one step, then he take two step, and then he will be reach at the top, and this is the second possible way. Now if he don't follow this way, and what he can follow, now he can take two steps first then one step. Okay, so this is the third possible way. Is there any more chance to climb on the stair of three total count of stair? No. Okay, so there are three possible ways. Now it might be a case that you were thinking that how many stairs are there? Only that much possible ways are there. So let me tell you, here you are wrong. Okay, for 4, if the stair count is 4, the possible answer is 5. So here is a change of case. Okay, don't think that the number of possible ways will be equal to the number of stairs. Okay, this is not the case. Okay, so suppose n equals to 4. So there are four stairs. Okay, so this is one stair, this is two stair, this is three stair, and this is four stair. Okay, so first of all, if the person takes only one step, and one step, so he can reach at the top by taking one. All right, so this is the first possible way. Suppose the person will take Suppose the person will take first step, then second step, then he directly jump onto the top by taking two steps. Okay, so this is one and taking two, and this is the second possible way. Now, suppose the person first took the two step, then he took one and one. Okay, so this is the third possible way. All right. Now if he first go on first, then he take two steps and then one. Okay, so this is the fourth possible way. First, then two steps and then one step, and this is the fourth possible way. Now what he can do is he can take directly two and two steps. So two step and two step, and he is at the top, means two and two, and this is the fifth possible way. Now is there any more way? No, there is no more such way that he can reach at the top. Now, are you able to guess the idea that what type of problem it is? This is a recursion based problem. Okay, recursion based problem. How? That means suppose there is four stairs. Suppose there is four stairs. So if I have to count the total possible ways to reach at the top of four stairs, so what I can say, like, if you can give me the total possible ways to reach at the third stairs to reach at the third stairs, then I can tell you the total possible way to reach at the fourth step. Okay, now suppose you have given me the total possible ways to reach at the third way, so I can easily find out the total possible ways of reach at the fourth step. Right now, if you say that, can you give me the total possible ways to reach at the third step, so you will be reaching out to this and you will ask to this, how many total possible ways are there to reach at you. So it will go to here and it will ask for it, how many total possible ways do you have to reach at you. Okay, so this is how the problem is working in a recursive way. Now how does recursion work? So the thing is, now we have find out that this is the recursion based problem. Now how we can solve a recursion based problem? So first of all, we have to find out the base case so that we can break over recursion. Okay, so first of all, we have to find out our base case. Then we have to find out that what can be the recursive calls. Okay, so the second step is what can be the recursive calls, and the third step is basic simple calculation. Simple calculation. So if we can find out these three things, then we can solve our question. So as we can see here, here is the base case 1 and 2. If the n count is 1 and if the n count is 2, so you have to just return 1 and 2. Okay, so this can be our base case. Now, what can be our recursive call? So if I ask my previous step to give me total ways to reach at the previous step, then it can be a one recursive call. And if I ask to one more previous step to reach the way, to find out the total way to reach at that stop, so it can be our second recursive call. So this is how we can solve this problem. Now this problem is similar to Fibonacci's. Okay, this problem is similar to Fibonacci, means f of n equals to f of n minus 1 plus f of n minus 2. Okay, this problem is similar to f of n, this Fibonacci formula. That means the nth Fibonacci term will be the sum of two previous Fibonacci terms. Okay, so this will be the recursive call of these. So from here we can make a recursive call. Now for this, okay, and for this Fibonacci series, the base case is n equals to 0 or n equals to 1. All right. Now, but here in our case, the base case is n equals to 1 and n equals to 2. In that case, we have to return n only, and for other, we have to make recursive calls. Okay, I hope you guys the logic till now. Now, if I make a recursive tree, just a minute. Now, suppose if I make a recursive tree for n equals to 4, so it will be F4 I am taking here. So it will ask for the stair number 3 and the stair number 2. Okay, the total count of possible ways to reach at them. So it will ask for stair number 3, that means f minus 1 and f minus 2. So f3 and f2, right? So it will call for f3 and it will call for f2. Now f3 will again ask for f2 and f1, right? f2 and f1, and f2 is already our base case, so we will stop at here. Now f2 is our base case, so it will return us 2. f1 is also our base case, so it will return us 1. So it will be plus 1, so it will 3. So this will return us 3 and this will return us 2. Okay, so 3 and 2 will become 5. So there are only this will 5. So there are only 5 ways to reach at the fourth step. Okay, to reach at the fourth step. So this is how the recursion tree works here, right? Now if we make a recursive tree for n equals to 3, so what we will do, we will be calling f2 and f1. That means n minus 1 comma n minus 2, right? So we will be calling f2 and f1. So these both are our base case, so it will return us 2 only and it will return us 1 only. 2 and 1 will be 3. So for 3 steps the answer is 3 only. All right, so this is how we can solve our problem. Now it's time to code this problem. So let's go into the PS Code and there we will be code our problem. What is this code working here? Just give me a second. So this T is for taking test cases, and from here we are taking input for test cases. This while loop is running for test cases, and this n means the total count of stairs. Okay, and from here we are taking input of stairs. Now int base, it will call a function count base. So this function will return us the total possible base to count on the nth stairs, to reach on the nth stair. Okay, so the answer will be stored in this base and this base will be printed out from here. Now all the work will be done in this function only. Okay, now why I took here long as a return time, because it can be a large number of amount of possible base, so that's why I'm storing it in long. You can store it int as well, but for the safe zone I will store in long. Okay, so let's fill this function by our. So first of all we will write the base case if n equals to 1 or n equals to 2. So what we have to return, we have to simply return n. All right, now else what we have to return is we have to int, we have to make recursive calls. Recursive call 1 and this will be on count base and for n minus 1. All right, now int recursive call 2, there will be 2 calls for n minus 1 and n minus 2. All right, then we will be storing the answer and we will add these all, or you can directly call the recursive calls. Okay, and then you have to return the answer. Now let's run this code. For there are 4 test cases. So first line is for test case. Now if n equals to 1 and if n equals to 2 and if n equals to 3 and if n equals to 4. Okay, so let's find out the answer. So there should be equals to. Okay, so let's find out the answer. So the answer is for staircase 1, the answer is 1. For staircase 2, the answer is 2. For staircase 3, the answer is 3. And for staircase 4, the answer is 5. As we have done in our dry run time, right? So this was the code for problem of staircase. Now this problem can also be solved by DP in more optimal way. But DP is a little bit tough for you. So you can adapt this way only, right? So let's move on to the next problem now, that is also asked in recent Accenture exam. So the next problem is just a minute. For a given 3-digit number, find whether it is Armstrong number or not. Now, what is an Armstrong number? An Armstrong number of 3 digits is an integer such that the sum of the cubes of its digit is equal to the number itself. Return yes if it is an Armstrong number, else return no. Okay, so for example, 371 is an Armstrong number. Since now what the question is saying, the sum of the cube of its digit is equal to the number itself. That means these digits are 3, 7 and 1. So 3 cube plus 7 cube plus 1 cube. Now when we sum it all, so we get 371 only. So if this is equal, so this will be called as Armstrong number, and if it is not equal, then it will called as not a Armstrong number. Now let's take an example for 153. So let's find out the cube of 1, 5 and 3 and then sum it all. So this will be 1, this will be 125, this will be 27. So it will be 153 only. So this is an Armstrong number. Okay, so for example 2 as well, this is an Armstrong number. Now how we can do this? So we just need to find out the particular digit cube. Okay, so how can we find out a particular digit from a number, from a 3-digit number? So we learned about modulus operator. So suppose if I divide 371 by 10. So what I will get as the remainder? So this is modulus operator. So what I will get as the remainder? So if I divide 371 by 10, so it will be, first of all, 10 3 is 30. So here I will get 7 as the remainder and 1, 10 7 ja, so 1. Okay, so here is the 1 remainder. Okay, and 37 is the quotient. So 1 is remainder, so I got 1. What is the digit here? Digit is also 1. So this is how we can get our digit only. Now the number is, and then at last we will divide 371 by 10. So it is divided. So this time this will give 37. Now we will store this 37 in our number. Now our new number is 37. So we have to find out this digit. So again we will divide by 10 and we will find the remainder. So when we divide 37 by 10, so the remainder is 7. So this is how we can find our next digit. And we can take the cube of these digits one by one. So this is how we can solve this problem. So let's see it and let's see the code in VS Code. So this line is for sample test cases. We are taking input, and this while loop is for running the sample test cases. Now this n is taking input to check whether the number is Armstrong or not. And from here we are giving the input. Now this is a string answer. It will return us, it will be storing an answer in string format. And this is our function. This function will tell us whether the number is Armstrong or not. Now we have to code in this function, and then we will be able to solve our question, and I will tell you the solution in proper way. So first what we need to do is we will be taking a temp variable and we will be storing n in this. Now why we are taking this temp variable? Because when we perform some operation in actual or an original value, then original value will be got changed and we cannot compare with it Armstrong number, right? Because our original number has been changed, then how can we compare this with some? Okay, so we will store it in temporary variable and then we will be having some changes and then we will compare with the temporary variable. Okay, so let's first of all, here we need sum, so we will assign sum by 0. Now while n is greater than 0, till there we have to run our loop. So first of all, what we will find? We will find the last digit of the number. How we can find? N modulus 10. N modulus 10. From here we can find our last digit. Now sum assign sum plus, we need to take the cube, last digit into last digit into last digit. So this is how we can find out our cube. Now here we need to update our n. Okay. Now at the last we need to return, sorry, first of all we will check whether the sum we got is equals to temp or not. Temp means that original value that we have already stored. If yes, then return yes. Else simply return no. Your number is not an Armstrong number. Now let's run this code and find out the solution. So input is, first line is for test cases, and then 371 and 153. We are checking for Armstrong. Okay, now let's check. So the answer is yes, yes for both, right? 3q plus 7q plus 1q. What it will be? It will be 27 plus 343. Yeah, 343 plus 1. So it will be 371. So this is an Armstrong number. Okay. Now, what if we don't take temp equals to temp assign 9? What if we don't assign n value in temp? So at the last, here we got our n value as 3 only, right? Now if this time n value is 3 and this will go into while loop again, so it will again be changed into 0. Once it will be changed into 0, so this time n value is 0, and here if we are comparing it with n, sum is equals to, if it is Armstrong number, then what if we compare it to 0, 0 equals to that particular sum. So this is how our code goes wrong. So this is why we have take temp, because we are not performing any operation in temp and we are only performing our operation in n value. So this is why we are not comparing with n here. We are comparing our sum with the actual value, with the original value. So this is why the need of temp variable here. So yeah, that's all for today. In this video, we have solved two questions that are recently asked in Accenture coding question. I hope you guessed the proper idea. I hope the explanation was clear to you. So we will meet in the next video. Till then, bye bye and take care.